So hypergeometric distribution is very similar to binomial. What do I mean by that? Let's say you have n items in a box.
Okay, bye, Mom. I love you.
Oh, it's k items that are of one kind. Or items that are of the second kind or another kind. And n would be equal to r plus k. Good. So think of, you have a box, K Butterfinger bars, R Skittles bags, but everything wrapped in, in a way that you can't distinguish them. And you want to randomly pick items. And if I say that they are equally likely, I shouldn't say, that will confuse you. I should rather say replacement. I don't want to say equally likely with replacement. Long time ago, I mentioned that this replacement would imply dependent or independent? Huh?
I'm going to go with independent.
Independent. Logic, right? If that is wrong, this has to be right. So it would mean independent because you're putting things back and simple random samples when you collect observations, they are independent. So if that is the case, and if someone came up to you and said, well, X is the number of items of the first kind if n items are chosen. What is the PNF of X? Of course, we could go through all of them, but if X items are chosen and I go n times, I would like to know how many were X and how many were of the other kind. So in total, I have n items. I'm going to choose m out of them. Yeah. Out of those m, X must come from the first kind. So I'm choosing X from the first kind. M minus X from the second kind. So, way to visualize this, let's have a box.
Can you define what N and M are again? Because I feel like they've changed a few times and I'm really confused.
So N is the total number of items that we have.
Yeah.
M is the number of items I intend to choose.
But I thought you were choosing all of them in this.
That's why I changed, because if I chose all of them, it would become 1.
But because you have n as a parameter, and then also the definition.
N is always the parameter.
But you said that those are all the items in the box.
Yeah, and you also said that hyperconjugation means that you use all the
A
items.
hypergeometric.
Or, yeah.
We can use all the items, but it would be one. That's why I changed it to M items. So I'm only choosing M. So let's see, dot, 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 dot. 5 purple.
I'm sorry, but that shouldn't be M in the parameter. Since that's the amount that
That's
you're
what I
choosing. On the parameter, that you're choosing an item, not choosing M.
Because we switched that, thank you. Because since I switched that, this has to be that. Okay, so maybe I should put it as 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's a nice little circle. Okay, in total, how many do we have? 15, 8 there. 3, 3, 6, 7, 8, 13. So big N is 13. Yes. And how many of the first kind do I have? First kind, 5. How many of the second kind do I have? 8. If I add them together, does it match up to 13? Yes. Now, we could pick all of them, but it wouldn't make any sense, so I'm changing that to 10. Now, give me a number. The maximum that I could pick is n items, but let's say something less. M is equal, just by looking at this, what should the maximum value of x be? Okay.
12, and
If you look at this formula, what should the maximum value of x be? First kind, right? It should be 5. Because if you pick something bigger than 5, and you have a certain number of trials, this could become negative, right? Yes.
It should be 8, because you said K is 1 time, R is the other. Oh, so it's
So this is the first kind, right?
it should be equal to K.
Do I have it backwards?
Oh.
It doesn't matter, actually.
No.
Usually it takes the eight one or something, no? Use the same variables and apply to.
It really doesn't matter. Okay, so x, 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 which means you don't pick any of the first kinds.
you don't think that you roll.
Can you see it in the back? Okay. So one of the first kinds, 2 of the first kinds, 3 of the first kinds. Yes, we're choosing m equals 3. But just like binomial, we can swap the orders, right? The number of ways each of them could happen. How many ways could this happen? 3 ways. Wow.
Three.
That.
One. Yeah, that's one.
Good.
Yeah.
So that gives us 10. Good. What is 13, choose 3.
What's that equation equal to? Like what?
200.
That would be the probability that we would get x is equal to x. So probability of x equals x, in other words, x of kind 1 would be k, choose x. Because the first kind, we have x of them. The remaining must come from whatever that is left. So how many do we have left? Or how many do we have of the other kind? R. So in total, we pick m. If x of them come from the first kind, how many of them should come from the second kind? Total minus x, so m minus x. Out of all items that we have, how many did we pick? N out of m. Good. So in total, you have 15. I am picking 3 out of those 15. Does that make sense? Since they are distinct items, they're not identical items, but they're of the same kind, or you have to treat them as distinct items. The number of possible ways would be n choose m, total number of ways. For us to get x of kind 1 would mean I'm choosing kind 1 from the x that I have. That would imply the remaining must have come from m minus x. So here, the value of x is 0. Do we agree? None of them came from kind 1. Here, x is 1. Exactly 1 came from kind 1. That would imply how many came from kind 2? 2. So that would be m minus x. So m is 3. 3 minus 1 is 2. Well, obviously, that case has to be 3. Right? Next, we have 2 of kind 1, which would mean how many of the other kind? 1. So 3 minus 2, 1. And lastly, 3 of kind 1. That would mean how many of kind 2? 0. 3 minus 3, 0. Good. So the value of x here can go up to 0, 1, 2, and 3. Does that make sense? But of course, we can exceed, we can go all the way up to k, but we cannot exceed k, because in combination, this value cannot exceed that value. So the limit that we can put for x is 0 less than or equal to x, less than or equal to k. One requirement to satisfy that. What is the other requirement? M minus x is less than or equal to r. Could it be 0? Because of symmetry? Yes. So 2 restrictions, just because we cannot have, this number to be bigger than that number. So now do you see how we get x and m minus x? And we are choosing k items, we are choosing x items from here out of K. So K choose X. That would mean I have M minus X items I'm picking from here. So from R, I pick M minus X items. But in total, how many did I pick? M, but I picked those M out of how many in total? 13. So 13, choose 3. Does that make sense? Yes. Okay. Or boxes that are labeled, there's no probability here because it's certain, unless if I blindfold you, in which case you wouldn't know. So his example is, what are the two kinds?
I don't know, I guess it's frosted flakes and Fruit Loops.
How many frosted flakes do we have?
Probably like several hundred, I don't know, it's a lot of.
Okay, 70 frosted flakes and
There's a lot of frosted flakes about it.
24 Fruit Loops, okay?
But they have to be in the same box or the bowl? Or
Identical boxes.
If you want it.
They're all packed in identical boxes. Let's say brown boxes, no
So
color.
separate boxes.
Yes.
Get yourself cereal in the dark.
On the first example, I thought it was one box.
There's 2 boxes. Just like assume each one.
Each dot is a box of cereal in my example, right? I put box 1 and box 2 to indicate kind 1 and kind 2. So
Like when you listed out your hypergeometric distribution, like your rules, the first one was n items in that box. And then we did your example, you had 2 different boxes.
So imagine that big box has 2 different boxes in them.
Double box.
So N is R plus K.
Yeah.
So 17 frosted flakes and 24 Fruit Loops. Let's say we have 7 days. So Cassie, right? This is what I meant. Big box 1 is frosted flakes, box 2 Fruit Loops. In total, you have N. First kind of K. K of first kind, R of second kind. Does that make sense?
So in my brain, like, you know what box you're reaching into. Yeah, that's right. So it's like, I don't want to say biased, but like, if you know what you're reaching into, you're not.
That's why I said you don't know the outer, coloring of the box. It's just a brown box. They're all identical.
Usually mine are the drawer, you can't see any of them.
If you dump the 2 boxes of cereal, it still makes the same problem, right?
Yeah.
As long as dump it into 1 big box, now you don't have 2 boxes.
Yeah.
It picks,
There's 2 different
Right.
Yeah, as long as you have 2 different kinds. So Fruit Loops and frosted flakes.
yeah, you get the red apple jacks and the green apple jacks.
Okay, let's just keep it simple. We're not going to go to different brands of cereals, okay? So 7 days, and each time he picks out a box, he eats the entire box, which means without replacement, or you're feeding a family of 5 with the same cereal every morning. So 7 different mornings. Good. My question to you is, so what would M be if I'm looking at 7 different mornings? 7. Good. I am going to say X is the number of fruit flakes that I randomly picked from this box.
Fruit flakes?
Oh. Frosted flakes. So I'm going to pick from the first kind, which is frosted flakes. So come again.
Got a lifetime supply of frosted flakes.
So that would be a hypergeometric distribution, because in total we have how many? 70, 94. So n is 94, m is 7. How many of the first kind? 70. How many of the second kind? 24. Yes. So if I define x is the number of mornings when frosted flakes box is chosen. So 7 mornings. That could mean it could have happened all 3 mornings, or 3 mornings, 0 mornings, all 7 mornings. Yes, with me so far. So that would be x. And what are the possible values of x? X would go from 0 through 7. 0 would mean none of those mornings you picked frosted flakes. It was all Fruit Loops. 1 would mean one of those 7 mornings you picked frosted flakes. The other days it was Fruit Loops, right? When I mentioned symmetry earlier, it really doesn't matter what the kinds are. If I flip, it'll just be another hypergeometry. Does that make sense? We could have just gone with this example. But I would like another example. Okay, so a box contains 70 frosted flake cereal, 24 Fruit Loop cereal boxes. All boxes are identical in shape, form, everywhere you can think of. Each morning, Chris is blindfolded and he's asked to grab one of those boxes. If he grabs that box, he eats that entire box of cereal. And we're going to observe him for 10 mornings. First, are these 10 mornings independent or dependent on each other? Dependent, because the first day he picks a box, he eats the entire box, it's gone. So the total, it's going to go down. And the next day, same thing. So each day is going to depend on what had happened in the previous day. So it is dependent. And x will be the number of mornings when he chooses frosted flakes. I can easily change this problem to a binomial if I said each day after Chris picks a box, I look in the box, buy that kind and put it back in. Yes, in which case it will become independent immediately. And what distribution would we have? Binomial. Great. So this is hypergeometric, and first kind is 70, second kind 24, and how many are we picking? 10. So this would be K or M. So what are the possible values for x? 0 through 10. All we have to do is plug it in the formula and find the probability mass function. I could write the formula out of space over here. What is n? 94. N would simply be r plus k, which is 94. Okay. Again, it seems like a lengthy process. Of course, it's a lengthy process, but I'll show you how to do this easily, just in case there's a homework problem or whatnot. What is the first value?
2.17 times 10 to the negative 7.
Okay, second.
1.01 times 10 to the negative 5th.
Third. Oh, I mean, x is equal to 2. Go ahead.
1.96 times 10 to the negative 4.
Okay, next one.
0.002.
Next one.
0.014.
Next.
0.057.
Next.
0.154.
Next.
0.268.
Next.
0.288.
Next.
0.173.
Next.
0.044.
So, which is more likely here? Over here. And you know, on an average basis, it's going to be somewhere over here. Yes. If I looked at 10 mornings, it seems like 6, 7, 8, 9 are good possibilities for us to get frosted flakes. But does it make sense though from a practical way? Shay, why?
Well, you could think about it like there's 70 frosted flakes out of 94 total. That's about 3/4, and that's in between the 7 and 8.
Exactly. You have more of frosted flakes, and you know, this is approximately 3 times. So you have more of frosted flakes. So if you're picking 10 mornings and you're asking, well, how favorable would it be for us to get frosted flakes? Out of 10, 6, 7, 8 seems reasonable. Yes. The chances that you don't pick any frosted flakes at all is going to be very small. 0. You guys did it one at a time. You can do this simultaneously using your calculator. I'll show you how. All the things I have. So the very first thing that you have to do is to press second window. You have to change the settings here because we are trying to evaluate the formula. 0, 1, the independent variable is x. Instead of auto, set it to ask. Good. Second mode to exit. Go to y equals. Now this is where we've got to enter the formula. So k 70, choose x. Yes. 24, choose 10 minus x. The entire thing divided by 94, choose n, which would be 10. Good. So when you put it in the calculator, make sure you use parentheses properly. So 70, I believe it's under math.
Yeah.
So go over to PRB, which stands for probability. Select number 3. So 70, choose. Instead of a number, simply put x. Good. Multiplied by 24. Math. Number 3. 24, choose 10 minus x. And we're going to divide the entire thing by 94, choose 10. Round. Did we enter? Yes. So I just put, you can use this method in any class and say that you use calculators. All you're doing is evaluating a formula or a function for a whole bunch of values. So we have that now. Second mode to exit. Second graph. That's going to bring up the table. This is where you're going to specify the values for x. Then remember earlier when I did table set, I said switch it over to ask. This is why the calculator is waiting for me to give a value. So when I type 0, nothing works. Get that 1, 2, 3, 4, 5, 6. That seems weird. Did I type the formula wrong?
You need to put parentheses around your addition or the subtraction.
Give me 1 second. So once we put in, we get 0, 1, 2, 3, 4, 5, 6. And for some reason, this calculator stops at 6. So if you want 7, you can just change that to 7 and get that number, right? Same if you want 8, 8, and so forth. So these values match up to what we have. Do we agree?
Is the table working for, like, answer?
That the entire thing is the PMF, so the table is the answer.
So when you ask the 7, 8 question, like where would you ask that, or?
That would be a separate question. I'll do a problem. Are we clear? Yes.
Can you put the binomial
Any function.
Any function, you can put it in there. So binomial exponent doesn't matter. You could put any function. All you have to do is change that y equals pi.
How do you sum the list y1 to make sure you can mess up?
How do I sum the list? Oh,
Yeah, like there's a sum.
there is a sum button. So there is a lot of, what to say, particular details. I would say Google it. I'm not going to waste time on this. Shay was able to tell me that, you know, it is more likely that we will get 6, 7, 8, and many of you agreed. The reason being, if you looked at the probabilities, higher for 6, 7, 8, 9, relatively speaking. Yes. And the other probabilities are quite small, which in a practical sense makes sense because we have more of frosted flakes and fewer number of Fruit Loops. Here's the question. Call it B, part B, if that's A. Okay, so we want to find the probability that x is less than or equal to 9. As I went around, some of you did this. Nothing wrong with that. Union I equals 1 to 9, xi. Now, are the xi's disjoint? Yeah. Why?
There's like value vectors, so you can take two boxes, three boxes.
Okay. So mutually exclusive in a very exhaustive way. In other words, every combination of xi would be disjoint. So this would be sum I equals 1 to n probability of, each i. So xi, I mean x1, x2, x3. I'm sorry, this should start at 0, all the way up to 9, including 9. Nothing wrong with this. This simply means I'm starting at 0, adding all those values together up to 9. Sure, but there is an easier way to do this. I'm going to erase this first. What is the easier way? The probability of x less than or equal to 9 is 1 minus the probability of x greater than 9. Yes? But greater than 9 would simply mean I have only one possibility. That would be 1 minus the probability x is equal to 10. So 1 minus 0.044, that is 0.956. I'm going to erase this part too. How would we interpret this? Anyone can come up with a number. Okay.
You could say it is much more likely that he will eat the frosted flakes 9 or fewer days than it is that he will eat them more than 9 days.
That's a great way to explain. It's one of many interpretations. A simpler one would be, because this is inference, there are many ways to interpret this. I completely agree. What Shay said was it is more likely that Chris would eat frosted flakes on 9 out of 10 mornings than all 10 mornings, right? So at most 9 or 10, 9 mornings, at most 9. So the way I would say is 95.6% chance that Chris right? So we have to include 9 because it's less than or equal to. So there is a greater chance, and what is that chance? It is 95.6%. Can I erase this? Before I write the next one, does it make sense? 95.6%. Right? This is a good lead into the next thing that we would do, which is called cumulative distribution functions. At most would mean less than or equal to. So you're adding all probabilities. So as you go farther and farther, it's going to reach 1. Do you agree? So if I said Chris is going to eat at most 10 frosted flakes out of 10 mornings, that is true. Yes, so that is with probability 1, it is going to happen. So when you accumulate probability, you are going to approach closer and closer to 1. Part C. Morning. The one Ben is upset. It's not even paying attention. The answer is 99.99%. Don't round it to 100% because statistics is about randomness. And here it is a random event that we are talking about. So keep it to 4 decimal places. So does 99.99% make sense? Why? So if someone asked you, oh, explain this to me, why would you get to assume that they have no idea about probability? Would you say the probability less than 2, I'm adding from the PMF, I get, and subtracting from complementary rule, what 94, subtracting from 1 is 99.99. They're not going to get it. In simple terms, how would you explain?
Well, there's about triple the amount of frosted flakes as there is Fruit Loops. So the odds of,
Not odds, just
sorry, probability of choosing what the the one that you have fewer of so many times would be very unlikely.
Okay, close. Okay. Anything else? Why does 99.99% make sense? It kind of addressed part of it. I went over it more than once.
If you grab 10 boxes, one of them is way more than the other.
That's it.
The chance that you grab 0 of the one that's way more is pretty low.
Yes.
The chance that you grab one of them is pretty low. So like together they're going to be pretty low.
So the chances are I'm very likely to pick frosted flakes on at least 2 mornings. In the sense, 2 or more mornings, I am going to pick frosted flakes because the likelihood of me picking frosted flakes is higher compared to Fruit Loops. This is something we established at the very beginning, 3 times, approximately 3 times more likely. So naturally, the answer makes sense even before you start. If you take some standardized exams or whatnot, process of elimination is a great thing. So even before you start the problem, you can sort of think and get the answer. But how do we do this formally? Probability x greater than or equal to 2. 1 minus the probability that x is less than 2. What would probability x less than 2 mean? It would mean x is equal to 1 or x is equal to 0. Are they disjoint? Yes. X can't be 0 and 1 simultaneously. So probability of x is equal to 0 plus probability of x is equal to 1 of the 2, that's about 0.00001. So this would end up being 0.99995 or 6. Doesn't matter. Oh, have it at 0.9999. Don't write it to 1 because we are looking at random events. Yes.
So you don't want whoever is looking at this to think, well, it's a certainty, because 100% kind of means certainty. So you would say, you would just get as close to that as possible.
Yeah, and the reason for that is, all of these are related to practical situations that are random. And for me to say, oh yeah, it's going to happen with 100% chance, that says to people that I could never be wrong. But statistics doesn't work that way. When you observe a random process, there has to be some amount of randomness, which is why we don't count it. No matter how small the probability or how large the probability is, 99.999 or 0.00000, right? Do we understand hypergeometric? Yes. So this would be the last topic for the exam.